This video covers trig P.5 or pre-calc 1.4. Notes, this is going to be part 1. The topic for this section of notes is dealing with functions. So let's first talk about what a relation is, and then we'll start to define a function as we progress through here. So a relation is just a set of ordered pairs. And you'll notice that I have an example here. This is a set of ordered pairs. Ordered pair consisting of an x, comma, y. When we talk about the domain and range then of our relation, we're talking about either the x or the y values, depending on if we're talking about the domain or the range. Domain is x, range is y. So in a relation, the domain is the first set of the elements. I shouldn't say first set, I should write it the other way. I should write it as a set of first elements. Easiest way to remember that is it's our x values. Range, on the other hand, would be the set of second elements. Or, specifically for our example, it would be the y values. So if I asked you to find the domain of this relation, the domain would be 1, 2, and 3, because those are my 3 x values. You'd want to put it in set notation with those brackets around the outside. Do the same for the range. The range would be 2, 4, and 6, because those are the y values. So domain is x, range is y. This leads us to then our definition of a function. So a function is a relation in which every element in the domain, so every x value, corresponds with exactly one y value. Each x has one y value. Okay, that is the definition of a function. So what we're going to be doing in this section is I'm going to be showing you different ways that you can test to see if the either relation that you have or maybe a graph that you have, if it is a function. So we're going to do some tests to see how we can determine what is a function. So let's look at an example next. So if I asked you, are these a function, this set of x values and this set of y values, does it make a function? You have to answer the question, does each x have one y? This x has one y, this x has one y, this x has one y. So yes. So it is a function. What about this one? Does each x value, in this case 7 and 8, does it have one y? No. 7 has 2 different y values. So no, this would not be a function. X equal to 7 has 2 y values. Looking at this next one, 2 goes with 3, 4 goes with 8, 7 goes with nothing. Okay, there is nothing there that it's matched up with. So this would not be a function because x equal to 7 has no y value. And again, the definition of a function is each x has to have one y value. This one didn't have a y value at all. This one had 2 y values. And this one was the only one that actually had every x having only one y value. Next example I want you to look at is a graph. We're taking the square root of x minus 3. And I'm going to ask you the question, is this graph a domain? Or, excuse me, is this graph a function? And what is its domain and range? So when you have an equation, and I'm asking you to tell me what the domain range is and to answer the question if it's a function, the easiest way to do that is look at the graph. So I would invite you to put this into the graphing calculator with me, or you can just look at the graph that I have here. So the question for you is this a function? Well, by definition of a function, each x value has to have only one y value. Easiest way to tell that on a graph is the vertical line test. If you can go through and draw a vertical line on your graph and it only touches your graph in one spot, then the graph that you have is a function. So this graph passes the vertical line test, so we would say yes, it is a function. I'd want you to tell me why it's a function, so you would have to say it passes vertical line test. And when I ask you to find the domain and range of an equation, the easiest way I think to do that also is to look at the graph as well. So let me erase this. So if I ask you to find the domain of this graph, I'm asking you to find the x values that work. Well, here's where the graph starts, and notice that the graph is just going out here to the right. So only these x values are working. Well, those are the x values from 3 on. So x has to be greater than or equal to 3. If I'm not sure if it's equal to 3, put a 3 in here, see if you get a true statement. 3, not a true statement, see if you get a real number as an answer. When I put a 3 in here, I get the square root of 0. So it'll work out. Square root of 0 is 0, so 3 will work. When I find the range is asking what y values work. So my graph starts here, and it's going up. So on the y-axis, it's starting at 0, and it's going up. So the y values that are working would be the y values that are greater than or equal to 0. Again, the easiest way to do domain range and answering the question, is this a function, is to look at the graph. So I'm going to stress that to you in the notes here because I want you to look at the graph of these when you are working on your homework. Look at the graph, and then, because a lot of us are visual learners, we can visually see what x values and what y values are working, and we can visually see that yes, this graph passes that vertical line test. Next concept we want to talk about is something called function notation. Function notation is where we replace a y with an f of x, or a g of x, or in this example it's an h of x. Don't let the notation fool you. F of x is just a way for us to label this as the f graph. H of x is a way for us to just label this as the h function, or the h graph. So don't let that confuse you. How we use f of x notation or function notation is if we know that f of x is equal to 2x minus 3, and I want you to find f of 4. F of 4 just means, I said f of 4, but I wrote f of x. F of 4 just means plug in x equals 4. And since this really is our y, I'm only plugging it into this side. So I'm going to say y would be equal to 2 times 4 minus 3. So I replace this x with a 4. And I would get y equals 8 minus 3. So I'd get it equal to be 5. So, and then what I would want to do, because I changed f of x to a y, is to put it back as f of 4 equals 5. So when x is 4, y is equal to 5. That's all that this is saying. But when we put this f of x in here, students tend to get confused by that. So don't do that. That's just a labeling mechanism. So if we apply the same concept, when we plugged a 4 in for the x here, when it says h of t plus 2, you're going to put a t plus 2 in for the t. And in this case, there's 2 different t's. So if I rewrite this as, instead of t squared, it's going to be t plus 2 squared. And then instead of minus 2t, it's going to be 2 times t plus 2. And then to solve this, I'm going to have to FOIL this. So if I rewrite it out like this, I'm going to get t squared plus a 2t and another 2t makes 4t plus 4. Then use the distributive property here, negative 2t, negative 4. Combining like terms, we would end up with a t squared. These two are like terms. 4 minus 2 would be a positive 2t. And then 4 minus 4, they actually will cancel each other out. So I end up with t squared minus, or plus 2t. So sometimes I'm going to get a nice answer like a number, but other times I'm still going to have a variable involved in it. So again, with function notation, you're just replacing whatever the variable, in this case a t is, with whatever is inside of that set of parentheses. Over here it was a 4, so replace x with a 4. Over here it was a t plus 2, so replace both t's with t plus 2. Next concept I want to discuss is something called a piecewise function. It's called a piecewise function because I'm giving you 2 different pieces, or 2 different parts of the function. And then only certain x values work for each of these different parts. So for the first one, I'm only going to use x values that are equal to or less than -1. And for the second part, I'm going to use any x values that are greater than -1. So I've got two different questions up here for you. I want you to find f of -2, and I want you to find f of 0. You have to figure out which one of these two you plug it into. So since I know that -2 is, since my number over here is -1, since -2 is less than -1, I have to use this version of the formula. So I'm going to plug in x equals -2 into the x squared plus 2 portion. So you have to figure out which one of the two pieces you use based upon the domain. -2 fits this domain, it's less than -1, it's not greater than -1, so I plug it into here. So -2, make sure you use parentheses here, squared plus 2 gives me 4 plus 2, or 6. On the other hand, when I find f of 0, when x is equal to 0, that's greater than -1. So I'm going to use this function. So I'm going to plug x equals 0 into -x plus 4. So -0 plus 4 would just give me 4. Make sure you understand that by definition of a piecewise function, they're giving you specific x values that work. You have to identify which x value does this work in, and which x value does this work in, or which equation does this x value work in, and which equation does this x value work in. You don't plug them into both, and that's the common mistake I see students make, is they'll plug -2 into both of these equations. You have to look at the domain. The domain is a huge concept of this piecewise function.